Hello everyone, I am Professor P.S. Gosavi from Department of Electrical Engineering. Today we have to talk about the microgrid. In this we have to topic cover the first is introduction to microgrid operating modes, driving factors for a microgrid, interconnected microgrid. Then how microgrid deviates from a traditional distribution system, challenges in microgrid control strategy, then protection and safety, environmental aspects, microgrid advantages and disadvantages, future scope of microgrid. First is introduction to a microgrid. What is microgrid? Microgrid is an integrated power delivery system consisting of interconnecting loads and distributed energy resources. Microgrid can be operated in a parallel with the conventional grid or in island mode. Microgrid consists of a fuel cells, microturbines, reciprocating engines, wind power and PV array system, which are together called microsources. Excess power can be sold to a utility grid or it can draw surplus power to its load. Next, microgrid consists in this distributed energy resources, next loads, storage devices, controllers, point of common coupling. Introduction to a microgrid differentiator. In this conventional DAR and next is micropadigram. In this many points of coupling, lack of system coordination to take full advantages of DAR assets, then complexity in a grid interconnection, utility next point of common coupling to the grid, system coordination and optimization for asset utilization, grid connected and or island operation to increase availability, achieve benefits to a utility and end users. Introduction to a microgrid. Microgrid operating modes. In this there are four feeders are used: feeder A, feeder B, feeder C and feeder T. Grid connected mode. First, utility grid is active, static switch is closed. ABC feeders are being supplied by utility grid and micro grid, and T feeder is supplied by a utility grid only. Utility island mode. Next is island mode. Utility grid is not supplying power. Feeder D is not supplying power. Next is static switch is open. Static switch is open. Point of common coupling. Next is feeder A, B, C are being supplied by a micro sources, and feeder D is dead from a micro grid view. Next is increasing power demand. Emphasis on a reliability, quality, price of power. In this driving factors for a microgrid. In this increasing power demand on a reliability, quality, price of power, consumer choice, transmission concentrate, driving generation sources closer to loads, environmental issues. Interconnected microgrids. Practical size of microgrid is limited to a few megawatt. For a larger loads, it is desirable to interconnect many microgrids from a larger microgrid network called a power parks. How microgrid deviates from a traditional distribution system. Microgrid has two modes of operation. Its short circuit capability changes when the mode of operation changes. MG allows bidirectional power flow. Microgrid has a power electronics interface, so it can provide high level of fault current for relays. Challenges in a microgrid. Distribution protection and control practice is largely incomplete with the microgrid concept. Non-conventional generation will require new unit control and protection strategies for a successful microgrid operation. Supervisory controls will be needed to achieve the full operating potential. Tariff structures are potential in compatibility with multi-party microgrids. Control strategy. It has mainly three types of control levers. First is microgenerator controller, microgrid central controller, distribution management system. Since microgrid is an inverter dominated grid, it has an inverter control strategy. PQ inverter control, VSI controller. Protection and safety. In a traditional distribution system, power flow is a unidirectional. We use overcurrent and earth fault protection. But in a microgrid, first it should identify whether the fault is inside or outside of microgrid. Environmental aspects. Microgrid encourages the uses of the renewable energy sources which are environmental friendly. Large land use impacts are avoided. CO2 emissions are reduced due to the usage of renewable energy sources. Microgrid advantages and disadvantages. First is advantages. In this ability to disconnect from a utility grid during a disturbance and operate independently. Then disadvantage. Voltage frequency and power quality should be at acceptable limits. In this advantage, it reduces demand. It reduces demand on a utility grid, thus prevent grid failure. Next is we can use both electricity and heat energy so that overall efficiency increases. Next is advantages of microgrid. First is voltage frequency and power quality should be acceptable limits. Next, requires battery tanks to store which requires space and maintenance. Resynchronization to utility grid is difficult. Protection is difficult in a microgrid. Future scope of research. Voltage and frequency control under a various modes of operation protection scheme for microgrids. Transition between grid connected mode and island mode. Next is transformation of microgrid system today. And island mode. Transformation of microgrid system today into the intelligent, robust energy delivery system in the future by providing significant reliability and security benefits. Development of tariff structure for a multi microgrid. Thank you for watching video.